Greetings, Miss Scavoni here. We are going to be talking today about statistics. This one goes out to all the math teachers at Downers North High School who put up with my struggles. I made it here today to the point where I am a maybe semi not really credible person to be talking about statistics, but I will give you my limited statistical knowledge of just what you need to survive AP Psych and statistics. If you're not a math person like me, that is okay. I am the most not math person there is, and I made it through and now understand a smidge of statistics to impart my wisdom for you. So that's what we're talking about today. Um, Looking forward, our first exam is on Monday, so just keep that in mind. Okay, so let's get into it. There are two types of statistics that we need to know in AP Psychology. There's descriptive, which is basically what the name says. It's describing data. So it's identifying in a set of data what's the mean, what's the median, what's the mode. Right, finding those descriptions and those trends. Then we have inferential statistics, which is useful in applying this to the real world. So we need inferential statistics to allow us to kind of see if our data is actually any good, if it's something that we can take and apply to the world and, make that useful. Okay. So let's talk about the different types of descriptive statistics. Two that we need to know are measures of central tendency and then measures of variation. So it's really important that we are able to know what types of measurements fall under measures of central tendency and then what types of measurements fall under measures of variation. This is very useful because sometimes AP will do some kind of multiple choice question in which it's saying like which measure of central tendency looks at the average result in a set of data. Hopefully, you know that's the mean. But if you don't know that, but are able to at least know, okay, mean, median, and mode are measures of central tendency, and range and standard deviation are not. Those are measures of variation. You can at least eliminate two things from the multiple choice and help you narrow down that. So, again, if you're not mathy like me, just kind of knowing those basics can help you get where you need to be. So, we're going to see that sometimes, though, we need things other than measures of central tendency because sometimes measures of central tendency don't tell us the full story when looking at a set of data. And we see this here with the mean. We have an issue of something called skewed distribution, which sometimes happens when using the mean as a way of describing data. And this happens when you have random outliers in a data set in which you have someone who's scoring really high or on the kind of the extreme low end. And this is kind of skewing or offsetting your data. So it's not really showing us the full picture. So let's look here. This is looking at income for family in thousands of dollars. So we see most people are scoring, are falling within about 30 to $100,000. That makes sense, right? That seems like what the average middle class blue collar American might be earning. So why is the mean here then in $140,000? That doesn't make sense. We see this is a skewed distribution. We have, for example, your rich bajillionaires of Jeffrey Bezos, Elon Musk, whoever, right, who are the outliers, the top 1% who are earning so much, they're going so high that it's skewing our data set here. So that the mean, while yes, this is in fact the mean, it's the average, that's not really giving us an accurate picture, though, of what's going on in our society. So we need to add in measures of variation because this can kind of help us better interpret and describe the data that we're seeing in a better way. So again, same thing, know what are the measurements that fall under measures of variation, because again, this can help you if you are in a situation where they asked which of the following measures of variation talks about blah, right? You can eliminate all those central tendency ones and know that it's going to be range or standard deviation. Okay, so range is quick thing. Sometimes they might ask you to calculate mean, median, or mode. Remember, if you're doing mean just from elementary school, right, you're going to add up all the scores and then divide them by the total of scores to see that average. Mode, most frequent result. So what score is coming up the most out of all of them, if you count them. And then median, right, you're organizing from smallest to largest, the scores, and then you can go to find the middle result. So range, now let's go back to measures of variation. Range is the difference between the largest and smallest numbers in a set of data, right? So you're going to take the largest, the smallest, subtract, find what it is. But in terms of the most important one to know for measures of variation, that is standard deviation. So know this important term. Standard deviation is a measure of spread. It's looking at how far scores are or data points are from the average data point. We often see this shown in the form of a bell curve. And in psychology, it's often what we're looking at least for AP Psych. We usually talk about this in the intelligence section. So often we're seeing IQ scores or some kind of intelligence test. So this takes the form of a normal curve or a bell curve. And for IQ scores, the mean or the average is always 100. Standard deviation is, again, a measure of spread. It's looking at how far these scores are from the average. And this is something that's relevant, right? I would want to know the standard deviation if I were taking an IQ score. If I got 115 right here, I would want to know what my standard deviation was or how far I was from the average to allow me to know, am I above average in intelligence? Am I below average in intelligence, right? It's a useful thing to know. So the means here, one standard deviation, I said, is 15 points. And you can easily find this out just by looking at the graph. One bar is always one standard deviation. So you can just kind of do some simple math, right? What's the difference between 115 and 100? 15, right? 85, 100. These are all in increments of 15. So one standard deviation is 15 points. So we see here, if you are scoring one standard deviation above the mean, you would be scoring at 115. If you're one standard deviation below the mean or below the average score, you're scoring at 85. There's something important to note called the 68, 95, 99.7 rule. And this is just kind of a rule of thumb in statistics that 68% of scores fall within one standard deviation of the average. So 68% of IQ scores fall within just one standard deviation. So in here, 15 points away from the average of 100. 95 rule says that 95% of scores or points are going to fall within two standard deviations of the mean, right? So between 70 and 130. And then 99.7% percent of scores or points are going to score within three standard deviations of the mean, so 55 to 145. Right, so if you are outside of this 99.7, right, you're real unique and a really unique or rare case. So most people are going to fall within even more the 95, within two standard deviations. And if you aren't, we'll see that right once you get to 130, 140, this would be considered gifted, and that you're kind of going beyond what the average or typical person is scoring in terms of IQ. If you're below 70, that might be considered what would be like a developmental delay or maybe a cognitive delay. So we see here, right, it's asking you percentage of scores that lie within 70 to 130. Okay, that's two standard deviations from the mean. So that's our 95% rule, that 95% of scores are falling within the two standard deviations above or below the mean. If they asked you if an individual scored 145 on this test, how many standard deviations above average are they? All right, 145. So we can count 1, 2, 3 standard deviations. So that's kind of typically what they'd ask you and how you can kind of interpret the bell curve and kind of reading into how to navigate standard deviations. All right, so now let's move on to inferential statistics. Like I said, this is what allows us to make predictions. It allows us to say, is our data any good? Can we take this data? So think kind of like psychometric psychologists. Can we take this data from our test that we gave and can we know that these findings are legit and that we can apply or generalize this to the larger population now, apply our findings? So, an important type of inferential statistics we need to know is the term statistical significance. And if something is statistically significant, that's a good thing. Then we can take this and apply it to the larger population. If it is not statistically significant, it's just crap and it's just a coincidence. So, if something is statistically significant, the official meaning is that it's the likelihood that the relationship between two or more variables is caused by something other than chance. So, it means that there is a meaningful relationship here, that these two things are connected in some meaningful way. If something is not statistically significant, it means that these things are just related by chance, by coincidence. It's a fluke. They just happen to be related, but there's no meaning behind it. So this goes back to what I talked about with third variable problem, confounding variables, just this whole idea of spurious correlations that I talked about earlier in this unit. So he said that a spurious correlation is that the number of people who drown by falling into a pool positively correlates with films Nick Cage appeared in. This is not statistically significant, right? There's no meaningful relationship here. It just so happens that there's a coincidence that these data points are kind of lining up in relationship with one another. Yes, we see that they're correlated. No, it's not statistically significant. Right? It's due to chance. It's a coincidence, right? That the Nick Cage is not killing people. So, in terms of statistical significance, they might ask you a question on an FRQ, and I'll show us this in a sec. They might ask you, you read the little blurb about a study, and they might say, what does it mean if this data is statistically significant? That sounds confusing at first, but all you need to say is that if it's statistically significant, then that means the data or the relationship is not due to chance, that it's meaningful. So just say relationship not due to chance. Just kind of repeat this definition of what it means to be statistically significant. All right, so I provided some practice for you here if you want to use that. Here's an example of a multiple choice question you might see on a test though. So we have a test has a mean score of 90 with a standard deviation of 5. Which of the following scores is within one standard deviation of the mean? So again, it could either be one standard deviation above the mean or one standard deviation below the mean. So if our mean or average is 90, what's falling within one standard deviation? So that means it would have to fall within 95 or 85. So that means it would be B, 86, right? That's within one standard deviation. So that's an example of something you might see in a test. Okay. So I'll end with an example from our research methods FRQ. This is my AP Psych research methods FRQ. This is from 2014 when I took the AP exam. This one was kind of tough. I might have freaked out a little bit, but I survived. I was okay. So we see here they're asking you some basic stuff. They create a bar graph. That typically doesn't happen, but maybe. But I think I would have been thrown for a loop when I did that. I was like, but we see here, what I want to show us is they're asking, explain what statistical significance means in the context of this study. You don't even need to go back and read the study to look for something. You literally just need to say the definition and say, well, if it's statistically significant, then that means the results are meaningful and not due to chance. That's all you need to say. It's not due to chance. So I know I probably got this wrong thinking of just who I was in high school. I probably would have been looking for something like, oh my gosh, well, what does it say about it and here about it being statistically significant? But right, just knowing the definition that it's not due to chance, you'll be good. And you probably won't make a mistake that I would have made when I was in high school and freaked myself out about this. So there you have it. That is my very small knowledge of statistics for you. Please don't ask me to go more in depth. I can try, but I do not know much more beyond that. But you should be successful with that limited amount of knowledge. All right. Have a nice day, everybody.